Okay, let's do some modeling. I'm going to do some sinusoidal modeling. Sinusoids are just sine or cosine curves. Okay, I've got an example here I'm going to jump in with which is a Ferris wheel. It's talking about the height of a Ferris wheel over time. So, at some point you'd be on top of the Ferris wheel. At some point you'd be on bottom, and it goes around and around forever. So if you model the height over time, your height's going to go up and down and up and down and up and down, and it will look like a sine curve or a cosine curve, depending on your perspective. Okay. All right, so let's start modeling this. I'm going to write an equation, but it's going to take me a little bit to get there. So first, I've got this little picture of my Ferris wheel, pretty basic picture here. I'm going to take the numbers from the word problem here and translate them into the picture here. Okay, so the highest point on the wheel is 43 feet above the ground. Okay, if we look at this little xy axis, our time in seconds is going to be our x values, and our y values are going to be the height. So I'm going to put some xy pairs at these four important places. Okay, so if we're thinking about time, we're going to get on at the bottom of the Ferris wheel, and that's when the time is going to begin, right? You can think about starting your stopwatch when you first jump on the Ferris wheel. Okay. And then if we look at the problem, it tells us that it takes 8 seconds to make a full revolution. Okay, so that means at 8 seconds we're going to be down here back at the bottom. Okay, now we can figure out the time at these other places just from that. If it takes 8 seconds to go all the way around, that means it's going to take 4 seconds to go to the top. It's a pretty fast Ferris wheel, I guess. Okay. And if it takes 4 seconds to get to the top, well, hey, this is halfway to the top, so this is going to take 2 seconds. Now I can see every quarter turn is 2 seconds, so 2, 4, this would have to be 6, and then back down to 8 there. And we could go, this would be 10, 12, we could go around forever, right? But I'm just going to put that first revolution onto the picture here. Okay, it says the highest point is 43 feet above the ground. So that means at 4 seconds, when we're at the top of the Ferris wheel, we're going to be 43 feet above the ground. Okay. It's tempting to think at the bottom we're at a height of 0, but let's think about this for a second. So we used the 43, we used the 8 seconds. It tells us now that the diameter is 40 feet. Okay, so if this is a diameter right here, so that means there's my radii, right, of 20 and 20. So if it's 40 feet to the bottom, if I took the maximum minus 40, that means this would start at 3 feet, which kind of makes sense. The seat doesn't actually touch the ground, right? It would be raised a little bit above the ground so that it doesn't scrape on the ground and you can sit down on it, okay? So that's going to be your height at the bottom. And, at 8 seconds, you're at the bottom again, so there's 3 feet as well, okay? And this y value is going to be, it's going to be the average of it's going to be right in between 3 and 43, okay? So if you take your maximum height and your minimum height and average them, that's going to give me that height. So 3 plus 43 divided by 2 is going to be 23, okay? So that middle height is going to be 23, and we're at the middle over there as well, okay? So what I'm going to do with these points is plot them on this xy axis, okay? So got these xy pairs, and looking at the x values, I've got 0, 2, 4, 6, and 8, okay? So 0 is going to be right here, right? And then you could put 8 ticks actually, but I'm just going to count by 2 so I hit these 4 important ones. So I'll put 2, 4, 6, and 8. Okay, and then I also want to hit the y values I've got here. So looking at these y values, there's the 3's down there, 23, 43, here's another 23. So there's only 3 places for the y's that I need plotted, okay? So 3 is going to be pretty near the bottom, and I don't want to make 43 ticks, so I'm just going to put a 3 down here. And then 43 is my maximum height, so I'll put that near the top, okay? And then I know 23 is going to be right in between these two, so I'm just eyeballing 23 in there, okay? And now we can plot these points. I got 0, 3. Oh, by the way, my midline is going to be right here. Okay, this is going to be one of those curves, and we can make a road map. So all my critical points are going to be on those three lines. Okay, so there's the first one. Then I have 223, 443, 623, and 83. Okay, and hopefully that's looking familiar. And I knew this was going to be a sinusoidal curve, so it's sine or cosine. So I'm not just going to make kind of a V-looking thing. I'm going to make this curve a little bit. And then I'm thinking to myself, well, sine or cosine. And to me, you could actually do it with either one, but it's going to be easier to do it with cosine because then we don't have to do a phase shift. Okay, so this is going to be a cosine curve. It's going to be a cosine curve with a reflection because your parent graph for cosine would be a valley and not a hill, right? So this is flipped over the it's reflected. Okay, so I'm going to use all of this to write my equation. Okay, so let's gather some info from this picture. The amplitude is the distance from the midline to the top or the midline to the bottom, but I'll use this right here. So my amplitude, well, that's going from 23 to 43. That means my amplitude is going to be 20. The difference between 43 and 23. Okay. The vertical shift is how far the midline is from the x-axis. So that's going to be this distance. This is my vertical shift. Just put VS for vertical shift. Okay, and that's going to be 23. Okay. Another important part here is the period. Okay, so the period, remember, is the length of one cycle. And here I've got one cycle, so my period is 8. Okay, now it's going to be important to find the k value because I'm not going to actually put 8 into my equation when I write my equation. So what I want to do for the period is think, okay, for sine or cosine, I'm using 2 pi over k for the period. So my period is going to be 2 pi over k, and I also already figured out that the period was 8. So now I'm going to solve this for k. Okay, and you could multiply both sides by k and then divide by 8, or you can do what I call the incredible switch. Those are just going to switch positions. So I didn't leave myself much space here, but 2 pi over 8 is going to equal k, and then I'll just reduce, making this real small here. 2 pi over 8 would be pi over 4. Okay, so now I got that k value. Okay. And now we can start writing an equation, okay? So let me zoom out a little bit here so you can get back up. Let's write an equation, okay? So I know I was going to have that reflection, so I have my negative here. The next thing up is going to be the amplitude, right? So this is going to be 20, okay? And then it's a cosine function. All right, this next slot is going to be my k value. Okay, so this was my amplitude, right? This is going to be my k value. I've already figured that out way down here. It's that little guy there, pi over 4. Okay, and then I don't have a phase shift because I haven't moved this left or right. If I did have one, that's supposed to be a 4 there. If I did have one, it would go inside the parentheses here with the theta, okay, but I don't, okay, and then the last piece is my vertical shift, and this has gone up 23. That's my vertical shift, okay. Now you may want to rewrite this equation so that instead of y and theta, you have h and t for height and time, okay, and remember my y's are the h, so here maybe I'll do that here. My h is going to be the y, and instead of theta, that's going to be the x values, so that's time. Just because for the next part of this problem, you're going to want to plug one of those pieces in. It's a little bit easier to see now that I've got it written like that. Okay? So now I'm going to use that equation to predict my height above the ground at 4.5 seconds. Well, just looking at the Ferris wheel, 4.5 is going to be somewhere in here. So I'm expecting it to be a little bit less than 43, definitely quite a bit more than 23. I'm expecting it to be a lot closer to 43 than 23, okay? But let's see what happens. Let's use the equation. So all I have to do is plug in that time. Okay? So I'm going to start simplifying this a little bit. I'll start in here. Okay, and now I'm going to figure out this part with a calculator. I don't know what the cosine of 4.5 pi over 4 is, but I do know that I have to be in radian mode here. And the reason why is because we use 2 pi over k for the period, and 2 pi refers to the radian measure of a full circle. Okay, so on your calculator, make sure you're in radian mode. Let me check here. I am in radian mode. There it is. Okay, so I'm going to put in the cosine of, let me clear this other stuff off there, cosine of 4.5 pi over 4. Okay, so I've got that. Okay, so I don't want to round my answers until I get to the final answer, but just for writing this down, I've got that so far, okay, and we'll do my multiplication. So I'm going to multiply that nice long decimal I got in my calculator by -20. Now I've got about 18.48. Okay, and then I'll add 23 to that, and now I can round my answer and just say that it's rounded. So this is going to be about 41.48. I'm going to go to the nearest hundredth. And that is my height in feet, right? So don't forget the units there. And that makes pretty good sense. Let me separate this work there. Because remember, we thought it was going to be a little bit less than 43, because 4.5 seconds would be a little bit past the top. So it would be a little bit lower than the top, okay? Okay, sorry if I had a weird edit there. All right, so on the next page, there's an example just like this. I'm going to move through it a lot quicker, because it's just the same problem with different numbers, and don't want the video to get too long. Okay, so here we go. So got some new numbers here. I still know this is going to be 0 when I get on, okay, when I get on the Ferris wheel. And this time it says it takes 12 seconds for this to go all the way around, so this would be 12 seconds as well when I'm back at the bottom. So the halfway to that is 6 seconds. I'd be at the top if it takes 12 seconds to go all the way around. Okay, and then halfway to 6 would be 3. So every quarter turn is 3 seconds. 3, 6, this would be 9, and then 12, we're back down the bottom. Okay, and now let's use the highest point is 38 feet. Okay, and we're going to use the radius or the diameter. The diameter is 34 feet. So if you split 34 in half, 17 and 17 like that. Okay, so each one of these radii is 17 feet. Anyways, 38 minus 34, that puts me down at 4 feet at the bottom. Okay. To find this height here, I'm going to average my lowest height and my minimum and my maximum height. Okay, so that's going to give me 42 over 4, or 42 over 2, which is 21. So 21 is that middle height. Okay? So now let's plot these points. These are going to be our critical points. Okay? So looking, I got 0, 3, 6, 9, 12. 0, 3, 6, just counting by 3s here. 9, 12. Okay? And then looking at the heights, that lowest point is going to be 4. The maximum is going to be 38. And these other heights are in between. Exactly in between would be 21. Okay, and the 21 will be represent where my midline is. The other two y values will be the top and the bottom of the roadmap there, okay? And all my critical points will go on these lines. So I've got 0, 4, 321, 638, 921, and 12, 4, okay? And just like the last problem, we're going to have a cosine curve with a reflection. Or you could do it with a sine curve, but then you have to introduce a phase shift. It's a lot harder, okay? So let's start gathering some info here. Here's my amplitude. So going from 21 to 38, well, it's just the radius of the circle, right? It's going to be 17, okay? My vertical shift is how far the midline is from the x-axis. That is 21, okay? And then my period I can see is 12. The period also equals 2 pi over k. Okay, so then I can use these to find k. I'm going to say 2 pi over k equals 12. And I'll do incredible switch here to solve for k. So that's going to reduce to pi over 6. Okay, and now I have everything I need to write the equation. Okay, so y equals, well, my y is the height, so I'll put in height for h for my y. Okay, I've got that negative to give me the reflection. Now my amplitude is 17. Okay, I've got cosine, and then I want my k value, which is going to be pi over 6. Okay, this is going to be t, or you could put theta if you wanted to, and then the last piece is the vertical shift plus 21. Okay. Okay, there's my equation, and then we're going to predict the height at 7 when we've been on the Ferris wheel for 79 seconds. So I'm just going to take that equation I just wrote, put in the 79 there. Okay. And just simplifying that a little bit. Okay, I'm going to put this into my calculator. Don't forget to be in radian mode. I already am in radian mode. So let's see, cosine of 79 pi over 6. Is that okay? I'm going to take this nice decimal, multiply that by negative 17. And then add 21 to it, and I'll have my final answer. So I got about 35.72, and that height was in feet, so don't forget your units. And there we go. Okay. All right, that's it. I will see you next time.